Okay, rifled bed knives. By the way, my apologies for this drawing of a reel. I'm gonna have to talk to the graphics department about that. That's the worst attempt at trying to depict a reel that I've ever seen. Okay, what is rifling? What causes it? What is the proper procedure to deal with it? And if you have no relief and the bed knife is so tight that the reel, so tight to the reel that it can't be turned by hand, are you going to rifle your bed knife? Okay. When I was at Toro factory a number of years ago, I asked one of the Toro engineers about rifling, and he told me rifling is the bed knife waving like the Tacoma Narrows Bridge. Look that up. Rifling is caused by a natural frequency. Then I started poking around the internet and I found a Toro patent that was submitted in 1969 and it was approved in 1973. And it says, reel mowers have long been plagued with the problem of uneven wear between the blades and the bed knife, also known as rifling, and the attendant vibration, chatter, and the deterioration associated therewithin. Mower reels have always been made with the blades thereof equally spaced from one another. Investigation and study has shown that the impact of the reel blades on the bed knife excites the first natural frequency of the bed knife. When this occurs, the bed knife vibrates at high amplitude and heavy interference results between the reel blades and the bed knife. The steady rate of vibration occurs at the same frequency as the impacts per second. Therefore, for an 8-bladed reel, as the bed knife oscillates through one cycle, the reel has made 1/8 of a revolution. With this phenomenon, the reel blades strike the bed knife at exactly the same position as the previous blade hit it, thus causing the aforementioned rifling. It has been found that rifling can be substantially minimized and in some cases eliminated by redesigning the reel so that the spacing between the reel blades varies from blade to blade. If you look up this patent, you will see the drawings that help explain what's written here. This reduces the dominant frequency content of the exciting force and thereby reduces the amplitude of vibration. Since each blade has a different angular displacement from every other blade, and what they're talking about here is a different angular displacement. They're talking about, since the blades are unequally spaced, this angle here is going to be smaller than this angle here. Okay, so that's a fancy way of saying the blades are unequally spaced. Since each blade has a different angular displacement from every other blade, and since successive blades are unequally spaced, the blades are out of phase with the vibrational frequency of the bed knife. Therefore, each blade strikes the bed knife at a different location than the other blades. In contrast to equally spaced blades, which strike the bed knife at the same position. I think what that's saying is that under some conditions, if the vibration, let's go back to the Tacoma Narrows Bridge analogy. What this is saying is that the bed knife, in some cases, when there's a natural frequency generated, it will excite the bed knife, and the bed knife will actually start waving. And if the stars align and the frequency is such that these the crest of each wave matches the number of blades, then the crest of each wave is going to be impacted by the every blade. Okay? And what I think is being explained in the patent is that let me close this door because I've got a garbage truck coming over here. This garbage truck is paying no attention to my sign that says there's a video in progress. Okay, so what I think is being explained in the patent is that this bed knife is being excited by a vibration, its natural frequency, and it's waving. And the crest of each wave is being worn away by the blades more than the areas of the bed knife that are in the bottom or the trough. Okay? So what I think is happening when rifling occurs is that these crests of these waves are being worn away more by the real blades than the other areas. Then when that reel stops and the bed knife goes back to its natural unexcited state, those areas that were the crest of the waves have been worn away more than the other areas of the bed knife, and you get these dishes in the top face of the bed knife. So I have noted, I've had 2 occasions in my 20-year career when I've had bed knives that were rifled like this. And I reground the bed knives and put them back into service, and they rifled again in the exact same places. So once a bed knife gets rifled like this, it's done. It should not be, I would expect it to be ruined. The temper, they've been tempered or annealed or whatever, and I would not attempt to regrind a bed knife that's been rifled. Okay, so that's what rifling is, and according to Toro, that's what causes rifling according to Toro. What's the proper procedure to deal with it? I think proper procedure is to maintain grind and adjust the cutting units according to manufacturer specifications. And then if you get rifling, then let them deal with it. If you have no relief, the bed knife is so tight to the reel it can't be turned by hand, are you going to rifle your bed knife? I have seen reels that had no relief, and the bed knife was adjusted so tight to the reel they could not be turned by hand. And when they were out mowing, they were screaming, as you can imagine. And those bed knives were not rifled. So I think that I'm convinced that rifling has more to do with natural frequencies and vibrations, which is pointed out in the Toro patent. I think that is a more likely explanation for rifling than just friction and contact between bed knife and reel. Now, I do think that not having a relief and excessive friction and contact may exacerbate rifling.